It's a little bit advertisement for the company I work for. It is Jakawa. It's a data-driven company which offers AI solutions, experience, and all of them are tailored for the customers. You can see we have offices all around the world, a lot of developers working on the projects, and yeah, a lot of projects actually. Here is a little bit of the services that our company provides. You can spend 10 seconds to see it. I'm not gonna go through all of them. There are a lot actually. There's something in the technologies, in the strategy, actions, it's a lot. So I'm Ovanis. I'm senior technical lead at Jakawa. I've got around 17 years experience doing software engineering. I haven't been working all the time like doing DevOps stuff. I've been doing stuff all around the web domain. So I've been working on a number of big clients worldwide while helping Jakawa. And as I already mentioned, I'm very passionate about AI and DevOps stuff. Recently been exploring a lot. But as we all know, this data science and machine learning is with us many years, not only recently as the boom started. So I'm interested in that technology since then, like 10 years now already. So I put some quote here: from repetitive DevOps task to automation AI agents. So why I put agents here? Because what I'm going to show, it's kind of they work 4 agents together, not only one. But as you see it, they need to be triggered, not yet autonomous stuff. In the end of the presentation, I will show you what remains. If someone wants to contact me, we can put effort together. Everything is open source, and I put it in GitHub so everyone can take it and test whatever is done. Okay, so now we'll start with looking at what is a typical flow. So everything starts with the Jira ticket, as you know. Someone needs to create the Jira ticket, add the explanation, description, acceptance criteria. Here and there, somewhere no, but in most of places yes, like QA steps, what the QA needs to be done to test the whatever is done, and then the ticket goes to the developer. But that needs the conversation. I mean, sometimes in live, sometimes through Slack, this ticket is ready. Take it, and then the developer creates the branch, make a plan how to do it actually, whatever's in the Jira, then code it, then commits, and once committed, the merge request needs to be opened. Once opened, needs communication with the QA in some way. This communication needs to be done. So QA is not a QA person or persons. They are not reactive. It means that if the merge request is done, it doesn't mean immediately start testing it. So they have something in their pipeline. Once they're ready, they start doing QA stuff, and then continues maybe second test on staging server and whatever, and then deploy. And sometimes there's a bug, so everything should start from scratch. And I was thinking, we all know how to automate stuff. Can automate pipelines, everything, CI/CD, all around the code. But we cannot we cannot automate the human work, the work that needs brain. So this is it's not relevant, of course, for everyone. It's just what I did based on the test I've done locally in the small server I have. But most of I see the code, it takes like 15%. Maybe for some it's different, the proportions is a little bit like that. Then there's QA features, and then we can see this the rest of the stuff that needs the communication, writing the tickets, check it, spend time to think about it. Sometimes the tickets get a lot of comments, and this is where the time goes. Of course, as I wrote there, LLM helps. We can copy paste prompts, do stuff, but sometimes it breaks because it's not something that knows what was not already done. We need to explain properly now I need this, I need that, then add some rules, do proper prompt engineering, but still the language model that we ask to do something, it doesn't know the whole context of it doesn't know the whole picture. And this was the thing that I would like to solve for myself. And I was thinking the idea automate the developer. So I know it sounds strange, but what if we can put there kind of agent to embed it in the workflow? Whatever it needs human, actually we use this AI agent. But what I did actually, I will review it a bit late, more when we go to more technical details, but it must be starting like junior developer, because it must be taught what is in the project. And slowly, gradually gets to senior, to middle, and then to senior, to be able to do more complex tasks. We can see on the top, when everything is done manually, Git, CI/CD, drush, deploy. So this is the place to mention everything is around Drupal done. So I don't know for the other system, maybe need different tweaks. But what about this copilot, so-called? If it's there, so I can go down to the second flow, second pipeline. So AI DevOps agent, so can do things actually automatic, can cut off the time that needs a person to spend physical time to write tickets, to read, to understand. It can do this for 2 seconds, 2 minutes. Depends how fast is the machine or the server. Okay, so here's the system architecture top over on the very top level. So to achieve this, I need to connect Jira, some Drush operations. In this case, can be any server. I just spin up EC2 instance, but need to mention here it's brand new. I mean, the website is not very heavy. It's not loaded with a lot of users. So, and I used LLM through Olama to install it locally. And how everything starts, we have one Jira ticket, then it goes to the command line. There is some CLI command, so each command triggers different agent. And one of the commands actually trigger the whole agents in the choreography that do the sequence job one after the other. Then this CLI pass goes through Python layer, and in this Python layer, is where everything is driven. There's a prompt builder there. We have LLM Core, as I mentioned, is Queen 2.2 coder. Maybe some of you knows already, but this is one of top 3 open source coder models. And it's completely open source. You can download locally, can fine tune it locally. It takes time, depends on the machine, but can be tailored to do stuff exactly to meet our needs. Then this next step is to decide what to do. If it's bug, it does patch. If it's a new feature, it manifests code. But before it commits, actually goes this code goes through sanitization, because you see in the end, I find out some blockers, because this LM can get a bit more ambitious than we want to go, and creates something that's not to be created, puts the code somewhere that's not supposed to be put in there, so it needs certain boundaries. Once this is done, the agent comes in and does deploy, for example, to staging. Once it's deployed, another agent, which I call it QA, goes to the server and then executes some steps. By the way, those steps are taken from the Jira ticket, from the fields. I call it like QA tests, QA steps, something like that. In the end, it goes back to Jira and sends the comment. Depends, it was successful or not, it adds the comment. By the way, it's changing through this process. It changed the Jira transitions in each step, adds the comment, tells what was done, what was not done. Also populates the GitLab merge request with what was after a code review, change the labels, and updates the GitLab as well. Here we'll show in detail how the things works, what's happened in the pipeline. We need to start with the plan. The agent does plan the things, how to do it. It doesn't take a long time, but just do the proper planning. It's one phase called plan. Then the plan is done, goes to generate. In the next slide I will talk more about the generate, how it's happened, because this is the brain of the system. But in short, now generate, it's where the brain lives. It, as I mentioned before, it decides either do patch or manifest new code. Then goes to the commit. As I said, next one, it's another agent, by the way. It's like a Git agent. It does proper branching, sanitizing, and then once everything's properly sanitized, secure, then pushing it. One is pushed, another one, agent, it goes and does a code review, as I mentioned already. Before that, it creates a merge. After that, and updates the Git. In the upcoming demo, you will be able to see it. And then deploys it to staging server. You see deploy here doesn't mean to production. It just, I mean, up to staging level. Production is left for a human to trigger the button, but I think nobody gonna risk AI to do this, I believe. So yeah, pushing to staging, and then QA agent goes and tests. And based on the test, grabs the test what was done and paste it in the Jira tickets, so everything is visual there. If human can go, check the comment, scroll and see step 1, 2, 3, 4, what was done, what was not. So let's open a little bit the hood about the AI brain. So everything starts with prompt builder. When I was doing it, I found out that simple explanation is not working because the model needs more, let's say, better prompt. And I found out the better prompt needs good context. And then, yes, start with prompt builder, get the context from the Jira, also from the other parameters. You'll see later, I will show it. And once it's done, it goes to LLM. It makes actually connects to API through locally to this Queen 2.5 coder. By the way, this model is trained only for coding, and that's why it's one of top 3 models, only for coding stuff. This is why it's been trained for. And if someone wants to play with it, can download it locally, and there is a tools to fine-tune this model and gets really stronger. And the one that I used is especially the versions Queen 2.5 coder. It's 14 billion parameters. This is run on a machine that can have 16 RAM, and the processor is M1. There is next version, which is really powerful one, which is 32 billion parameters, but it needs more RAM to be run locally. But it's really strong and really faster than this. But what I did here is kind of mediocre machine and can do so much. Then next level, when the brain kicks in and does everything, next level to decide if it's div or it's manifest. So it decides upon the description. If it's manifest, it's easier because it creates new code. By the way, created little bit. If someone is interested after that, can see the code. It's a little short memory. Last thing is kept there. Based on that, can act for next code. Then sanitization. It's by the way checks for PSR12, but this can be tweaked via variables. It escapes. What I found out, this model tries sometimes to escape the doors, so breaks the code. If it's a PHP code, that's escape before door and then breaks the code. It was a small thing, but took me hours to. And then what I found out, because of fast action, and it's only one model here, sometimes it struggles, so I need to implement some strategies, like I can see retry, keep alive, and extend the context window that we can wait the model to return the result. So I will explain now what will be the demo after that, after this slide. As I said, first we will see these things kicked from the command line. It's a command that's called copilot one shot. Once this command is executed, it takes only I'll show you, only this ID, Jira ID. And after pressing enter, it goes on and reads the Jira, builds the prompt. The prompt is built by taking the description, taking into consideration acceptance criteria. Then there is a prompt builder, which attaches to this description and acceptance criteria some Drupal specific prompt. And basically the prompt is like rule. We have a rule, we have task, context, constraint, format, and guardrails. Guardrails are needed because I found out that the module sometimes puts the code wherever it wants. But these guardrails tell it where to put it actually. If it's a module, custom module should go in modules, custom, and should be put there. If it's theme, should go in themes, customs, and so on and so forth. And then once this is done, it also automatically commits and pushes the code to GitHub. It takes no time, it's really fast. You will see it in the end. Then opens the merge request, descriptions and labels are added accordingly. Actually adds the comments for each step in Jira, and runs the QA tests, deploy if it's green. So let me show you so let me show the demo. Sorry about it. Messed up properly. That's that awkward situation. Oh, okay. I hope you all see it. I'm just showing this description. That's the prompt. It can be even shorter, but I wanted to make it more descriptive. You can see it's in to-do state, and this is the command with the Jira ticket ID, and now it goes off and shows what is done. Go to the directory, do some git commands. You see three files are created. I asked it to create a module, simple one actually. Now it's already in EC2, does a config import, check for the module, updates it. Here's the status are updated, and Jira is ready for release. You can see the comments already, and the transitions are changed. Start from to do and goes do till ready for release. Also, you can see the comments. This is the comment what was done in the EC2 instance, and merge request when bus merged what was done here. Merge request created, where is merged? And here you'll see the merge request itself. Basically here it goes too much in details. This can be tailored also, but I just wanted to prove it that we can do it end to end without a human. And here is after the code review, the explanation. And we can check the model. It's really a simple model. but this is claims to be junior developer, so it does that. The more time spent in the project, it gets stronger. I have an experiment, such a thing, but it would be irrelevant for this talk. It would take more time than 45 minutes. Okay, so let's get rid of this. Do this. Okay. Next one that I will show is similar thing, but first thing that we see, first thing that we saw already was full pipeline. All the AI agents together work in a choreography. What's coming next, this one, it will show only one part, only the first one, which reads the ticket and creates the task. Then the other agent that does review and merge, and then third one, which does only, in this case I call it EC2, goes and does QA stuff. All of those can be executed separately. For example, if I want, I can pass number of merge requests, list pool of merge requests, links to Copilot AI review merge, and it's going to go through all of them, and you will do code review. And there is a small switch that we can pass, not merge it, so I can do code review, populate it, what was after the code review, but not merge it. That means human can go and check. Similarly, you can pass a bunch of tickets, let's say, to Copilot QA EC2, and can go to the server remotely and can do tests for all of them. But let me show you now how this works piece by piece. What's this? Don't go down. Okay. It will be another ticket, of course. It's same prompt. It didn't change it, but it's asking to create another module with just simple help text. Here I needed to give it some precision because I found out when ask it to create precise PHP code, it does this strict PHP somewhere, whatever the site's supposed to be solved. It's acceptance criteria. This can be even a complex one. This is QA steps. Also can be complex. Depends how mature gets the agents. And here's just the first part. Read the Jira ticket, create the prompt, create merge request, and leave it there. We can see same thing. Actually show the commands that has been done. Create the branch. Follow also the PSR12. Add a feature, and then Jira ID and the name of the ticket. And then it outputs the merge request link. Also, the link is here available in the Jira ticket, like a comment, automated. Yeah. Here we will be able to see the merge request. Still too much description into it. Can be also tweaked, not to put too many, but you can see the labels also there. Who created it, what was done, and the changes. Simple again. And now we can see the second command that I added deploy. If it's omitted, you will not deploy it even. And you can see how it's the process of deploying it now. Actually, while deploying it, because it's sometimes too fast, it does check if the hash will match the latest staging. For example, if the staging is the branch, you can see what was happened here. It's in below. The deploy and test. Copy the prompt and paste it here. And also in the Jira ticket, because the more information, the better. And you see last part, QA stuff. It was done for 2 seconds. Yeah, if it's complex website, it will take more time, sure. But this is fresh one, so still comparing to heavy site, you'll be still be faster than human. I know there is a tools, but this QA, I will explain something that not yet done here, but what can be done to be really valuable. Okay, that was the second demo. Let me get rid of. Now a little bit about, I say here under 10 minutes, it depends. Network latency, you all know, it depends. So as I mentioned about guardrails, it needs to be, it appears that this module needs to be told explicitly where to put the code. So in order not to get too many bullet points here, I just added this web doc root modules custom, but I added full explanation that added to if it's a team, add it in the teams, modules custom. If it's module, you can see modules customs, some sanitization. I found out that when I ask it to do strict PHP codes, it decided to add this declare strict types and add it not on the top but somewhere in the middle. No idea why it decided like that, but after a little bit fine tuning and adding it sanitization, this was fixed already. And then retrieve and timeouts. This was an interesting issue that I solved. Sometimes when the deploy kicks and it claims the deploy is done, what I found out, the module wasn't deployed because of the fast push. The remote was not updated with the latest hash, so I needed to make it wait for exact remote hash to match it. If the latest hash matched the expected one, then continue to deploy. And because here's work only one module, sometimes it gets slow and then takes time and it quits. So I need to add some waiting, some process, some logic to wait until what's been asked is done. And so retries and timeouts were increased. So automatic commit and push is strict to PSR 12 validation, and this error aware fallback. If it's patch, sometimes I found out it needs to be a bit more trained on it, because when it's patch, it creates something that's not supposed to be there. Let's put it this way. And that's why I make it, in this case, to review it and fall back to JSON manifests if this fails. So it creates something new, and it doesn't merge it, but whoever supervised the AI can see this actually failed and there needs tweaking. And last demo, everything that was created now, it's kind of person needs to be aware from the command line how to do command line stuff. But what I decided even go further is to use Next.js and connect this through Fast API. So just if I have zero knowledge of the backend stuff, I just need to go to that UI, write the Jira ID, CCS something 123, press enter, and run the full flow. Or if I want to run just code creation, just create, just deploy, I also can do separately. I will do the quick demo and then show what are the tools in that choreography. same prompt, different module. That's the description that goes as a prompt, QA steps, and this is the ID that needs to be taken to the UI. And this is UI. It's look a little bit not suggest. I'm not a front-end person, so create it very fast. And under it, actually, the Node.js pulls what is done in the command line and shows it under the field. You can see below step 1, step 2 if someone wants to run this ticket step by step. Now it's already done. It went to the end. Deploy it, creates the code, test it, and this is all the steps explained one by one. And this I have to mention is done only by one module. What I will show next, but not gonna run out of the time. Cool. We'll show next is if someone wants to help, you can together make this strong. Can actually involve different modules for different agents, but they still work in choreography to the next steps to become really autonomous, because now someone needs to trigger. And you can see all already 3 tickets, and this ticket is also updated. I'm not going to bore you now to show via UI step-by-step stuff, just want to show end-to-end how it works. So the Jira transitions are changed gradually. If something was failed, it would have changed the transition and put the ticket back to development. And it's already merged. I had no time to go to click to show before that because it was so fast. It's just simple name, simple thing.
Maybe someone has one question.
Yeah, I will let.
We have some time.
Yeah, I'll have some time. Just need to show one more slide.
Sure. Just a suggestion.
Yeah. Just to show what is behind this, we have a local CLI that here in this case the fast API is in the core. So Next.js through fast API goes to that local CLI, and then I already explained. Take the Jira, do the prompt. Jira issues read properly. Yes, do the prompt. Pushes the code to GitLab. Do a code review. Then push to EC2 instance again. QA. Do the steps, drush steps, and then accordingly updates the Jira transitions and comments. It's not going to spend more time here because I would like to leave time for the comments. For the questions, and to show. This is just quick from my local 30 minutes experiment. If I do it manually and then took 2 minutes. It's of course we all know it's relevant. Depends how heavy is the server. But still, 30 to 2. Here I already explained it. Something that I learned through the process that needs to prevent the LM not to escape the variables, because tend to escape these doors. Sometimes at this PHP stuff, and it took time. Also this Olama times out needs to keep it alive. Also this declare strict types. Sometimes when we ask them all do something strictly, it tries to force it by code. And then last one, quickly would like to really leave time for the questions. That we see right now is agentic flow, but it's not autonomous. Yes, there's agents there, but in order to become really autonomous system, there needs to be planner agent, developer agent, and review agent, and finally deploy one. And to be really powerful, different LLMs modules needs to serve each agent. For example, if what's the difference? If it's autonomous, there will be last one, which is QA agent, should monitor the life, not the life, let's say not life, keep it till stage, monitor the staging side, and if it's under strict rules, and if it finds a bug or something, immediately creates the Jira ticket. Jira ticket is populated with proper prompt. From there, by its own, takes next one, do development, actually will be diff, not manifest, do the code review, deploy, push it to staging, and keep doing these checks. And QA and call to action, if someone wants to make this stronger, have idea how we can make this better, it's good. If you think it's rubbish, okay, don't contact me after that, but if you think we can all make it stronger, let's connect. I will make the code available, it's already in GitHub, it's in Python unfortunately. I tried in PHP, didn't work, decided to go with Python. And if someone has questions, feel free to ask. We have 5 minutes. Or if not, you can catch me up somewhere outside. Don't kill me, only for cooperation and questions. So if no questions, 5 minutes. You can grab the lunch. Thank you very much for your time.